All right, good morning. I'm Craig. I've been doing the Kubernetes thing for a little bit. I think to answer Bob's question, this room is twice as big as our first formal Kubernetes 1.0 release. My background, I spent a bunch of time at Google. Was responsible for building a compute engine, which was a fun exercise in bringing relatively traditional workload management to that kind of science fiction data center that Google runs. And then along with a couple of my buddies, Brennan Burns and Joe Beda, we came up with a crazy idea to go the other way. Like, what would it look like if we could bring that sort of Google style of cloud native management to the outside world? And obviously, Kubernetes worked out okay. So what I'd like to talk about is, I spent a lot of time thinking about why did it work, right? There were a lot of things out there that were sort of vying for the position as the sort of standard container orchestration framework. What were the key ingredients that enabled us to get here? Because I'll tell you now, 5 years ago, I never imagined I'd be standing here talking to you like this, right? We thought we had a shot at something that was really useful. But I think there were a couple of things we did well. Obviously, we've talked a lot about the strength and structure of the community. There were some things that folks were pretty clever, not me, some of the engineers I worked with were pretty clever about in terms of Kubernetes. And then I think there's a whole bunch of serendipity, timing, and frankly, some luck associated with the ascendancy of this project. But one of the things I kept coming back to in my head as I spent time with organizations that were starting to consume Kubernetes, that were bringing Kubernetes into their environment, that were encountering some of these patterns for the first time, was the idea that Kubernetes brought some really interesting capabilities into the data center that they really hadn't seen before, new ways of thinking about problems. And a lot of these can be tied back to my friend Brennan Burns, who was, he's a sort of Renaissance man. He does all kinds of crazy things. But he was also at some point a robotics professor, right? So the idea of control theory through the lens of modern applications and distributed system design is a kind of core thematic piece that shows up in Kubernetes. And this session, I'm really going to talk about how that kind of plays into the world of container app development, but more importantly, how to think about it from the lens of where Kubernetes goes next, some of the exciting opportunities. So let me just kind of get a sense of the audience. How many of you, this is your first Kubernetes event? Okay, not very many. How many of you consider yourself to be Kubernetes experts? Okay, bad news. You're still not going to be Kubernetes experts at the end of this discussion. Maybe by the end of the week you'll be closer, but it's not going to happen here. So let's talk about, first of all, what is Kubernetes? We're all okay, Kubernetes is a container orchestrator. It's a way to create a common infrastructure abstraction across all of your infrastructure. There's a lot of different ways to look at it. It's an open source technology. It's a community. It's a way to organize and run your systems. It's a way to bring a principled separation, as Bob mentioned, of continuous integration and continuous delivery. There's a whole lot of different ways of looking at this technology. But what is Kubernetes really, right? When you start thinking about the technology and you start digging in, what are some of the kind of core elements of the system? As you experience it, Kubernetes may feel like a wall of YAML and a lot of complexity, right? The first time you encounter the system. But when you start really digging into it and thinking through, what is the system? It's really quite simple, right? It's a big database called etcd. It's a way to get state, your intent on how the world should look, written into that database through this thing we call the API server. And then it's an intelligently structured set of controllers that read that state, observe changes in that state, and try to drive the world into that state, right? So this is kind of a deconstructivist way to think about the system. But think about it this way. I tell the Kubernetes what the world should look like, and then it's intelligently created a set of controllers that understand, and it totals all the way down, controllers on controllers on controllers, that then drive the world into that desired state. So this idea of controllers in the context of Kubernetes is incredibly powerful, right? One of the things that we did with Kubernetes that I think was pretty unique was focusing on establishing a very structured and sensible layering of controllers inside the system. So when you have something that you want to run, You write that state into the database. There's a controller that's sole reason for existing is driving the world into that desired state. So it could be something where it's like, hey, here's a replica set. I know that there needs to be precisely this many pods in existence. I watch the world. If there's one too few pods, it's pretty easy. I just add another one. If there's one too many, it's easy. I figure out one to terminate and remove it. But you can then layer controllers on top of that. You can layer a controller on top of a replica set that says, hey, once a day, I want this replica set to come into existence. I don't know what the replica set does. I just know that that replica set has to come into existence, run to completion, and then I'm done, right? So we were able to build up this layering of controllers on top of the system. And at the end of the day, what that means is that Kubernetes has a very different character as a distributed systems management framework than a lot of what existed in the world previously. Everyone thought about this whole system as like an orchestrator. So like, I have this, you have this one centralized entity that stands, front and foremost and makes decisions across the entirety of the stack. Kubernetes is more like jazz improv, right? It's about these controllers that understand in a very scoped way what the world needs to look like and will drive the world into that desired shape. And as a result of that, the system is entirely flexible. I was actually with a customer in, believe it or not, Texas, who in the most, I can't do a southern drawl, I wish I could, but he was like, it's a shotgun-proof system, right? I swear I could shoot this rack with a shotgun. And things would just move around, right? And I was like, well, you probably shouldn't be doing that. But a lot of what you're seeing and experiencing is as a result of these relatively self-contained, isolated, robust control systems that exist inside Kubernetes. As a result, you end up with a world where dropping an application into Kubernetes creates really positive outcomes. It becomes self-managing, self-healing. It becomes relatively easy to describe an upgrade cycle as a control process. I want to go from this version of the application to this version, and I can rely on the smart system to just drive it into that state. So that's a really positive outcome. Now, the interesting thing, and this is something that's starting to happen in the industry today, and it has significant implications that I don't think a lot of people have really thought through. There's a lot of secondary effects associated with this that I'll talk about that you should probably consider as we go. But those control patterns have applicability beyond just the core of Kubernetes. Everyone's familiar with how Kubernetes runs at this point if you're using it. That's great. But we can look at this mechanism of control and reconciliation loops beyond just Kubernetes itself. And the obvious starting point for a lot of folks is in the application domain, right? So it's like, why would I constrain my attention to just the Kubernetes constructs? Why can't I start describing in a first-class way in code how my application should be operated? When you start deploying real-world complex systems into something like a Kubernetes environment, there's always going to be some peculiarities around how things relate to one another. The mechanics of taking a system that consists of 20 or 30 different pod definitions and managing through the orchestration becomes challenging. Now, the good news is that construct has already been pulled into the Kubernetes ecosystem. How many of you are familiar with the operators framework in Kubernetes? Okay, you should all be familiar with the operators framework in Kubernetes, right? It's a very powerful system because what it enables you to do is start to describe, using this reconciliation loop, not just what needs to exist in terms of Kubernetes constructs, but creating a lot of application domain awareness in how something is being built and run. So you can take an existing piece of COTS software, it may be bundled with an operator that the vendor provides, you drop it into your Kubernetes environment, and it becomes almost self-aware. It understands what it should look like from a complex deployment perspective, and it will drive itself into that shape. It makes running things a lot easier. You're going to see a lot more of this over time. Now, here's something that you're going to encounter as we introduce a lot of these operators. As developers start to understand the utility of operators as it applies to moving their own distributed systems into this environment, it creates a spectacular layering violation, right? And I'm sorry, but not sorry, right? Like it's sufficiently powerful that it makes sense that you have this capability available to you. But it's also worth recognizing that as you start introducing these constructs, you're extending effectively the Kubernetes control plane. You're bringing application domain constructs into your infrastructure story. And that has some really interesting knock-on effects. If you're, for instance, in a financial services environment, you may get yourself to a point where you've worked carefully with your cyber team. You've worked through every permutation of how something may work. You've got your Kubernetes environment baked just so, and you're set up to be able to deliver namespace partition, multi-tenant Kubernetes outcomes to everyone, right? And then you're going to talk to your COTS vendor, and they're like, hey, here's my operator-driven XYZ. I just want to drop into your Kubernetes cluster. And your cyber team just freaks out. They're like, no way. That's never going to happen. And so what you end up having to do is be like, OK, well, I'm going to have to carve off another Kubernetes cluster that's configured for this. And what we start to see as we work, what I've seen personally as I've worked with a lot of big financial services companies, telcos, retailers, manufacturers, and other organizations that are bringing Kubernetes into their core environment, is that it's not a data center operating system. The consumption model is far more personal and granular. It's much more like a virtual machine in some ways than it is like a platform that you just pave out everywhere and have 1 or 2 or 3 clusters. And I think that speaks very well to the EKS mission, right? EKS is giving you a platform where at the other end of an API call, you get a perfectly formed Kubernetes cluster. And you can do that as often as you want. And that's fantastic. But that introduces problems in places that things like EKS just can't go, right? Like we still have to have a story, to Bob's point, around how do you create that CD model for the Kubernetes platform itself? How do we get Kubernetes deployed and operable and fully integrated and upgraded in environments where technologies like EKS don't exist, or in situations where you need something that is distinct, as Mark was talking about, from EKS in terms of that sort of fine-tuning process. Now, I'm a big fan of this pattern. You probably already figured that out from listening to me for a few minutes. How can that be applied to the infrastructure itself, right? Like, hey, we have a bunch of infrastructure. We know about it. We can describe it. A lot of that infrastructure exists in the cloud or on-prem or somewhere else. Can we take that same pattern of control metaphors and apply it to the Kubernetes ecosystem itself, like to the infrastructure that's running Kubernetes? Can we start to think about defining the infrastructure constructs in a way that Kubernetes itself can reason about? Now, this will bake your noodle. You'll be like, oh my God, he's going to create this recursive insanity where it's Kubernetes on Kubernetes and turtles all the way down. But there's a tremendous amount of utility in being able to get to a point where you can describe a point of infrastructure as a construct that a modern controller can reason about, where you can start to apply the Kubernetes API server and a lot of these Kubernetes constructs to this. And so one of the efforts that I'm most excited about in the open source ecosystem right now, well, there's 2. I love what's been done in the operator space. You should totally take a look at it. But the other space that we're looking at, really bringing a lot of these constructs to is cluster management itself. So SIG cluster lifecycle, and in particular, the cluster API initiative, which is really looking at using this model of Kubernetes to make it really easy to stamp out perfectly formed renditions of Kubernetes. So, in that project right now, the idea is that each piece of infrastructure should be describable as a Kubernetes custom resource definition. That we need to create a standard framework to reason about the provisioning and management of Kubernetes clusters on Amazon's infrastructure, on Azure's infrastructure, on Google's infrastructure, on VMware's infrastructure, on the metal pretty much everywhere, right? And that is really coming together. Now, the beauty of this is that by embracing a common framework for deploying and operating the underlying infrastructure that powers your cluster, you get this immediate community engagement. This is one of the things that I've learned through the Kubernetes, the sort of life in the Kubernetes ecosystem, is that if you can get something upstream, you get so much more intrinsic lift out of it. You don't get a lot of lag from being able to use something. And one of the areas that has distressed me as a sort of active participant in this ecosystem since its inception is this idea of the tragedy of the commons, where no single vendor is particularly incented to democratize the basic deployment and operation of Kubernetes. Like, why would they be, right? Like, it's a lot easier if you just have a vendor providing that system for you. And what we're starting to finally see is a breaking of the ice, where this community, the vendor community in particular, is coming together around these cluster API constructs. They're recognizing that we will be better served as a community by having a common way to reason about the provisioning, maintaining, and updating of Kubernetes infrastructure. And that it just gives you a lot of flexibility and options. Like, infrastructure has to be boring. I mean, Kubernetes is still way too interesting. Like, I hope that in like 5 years, like, no one wants to talk to me anymore. That it's just so boring. It just, it's hidden away. We stop worrying about Kubernetes. It just becomes another asset in our data center. And the path to get there is not by standing in the way of or trying to create, particularly fancy or interesting, unique ways to do this. It's really collaborating as a community, coming together and driving forwards. And so I would definitely encourage you to take a look at the cluster API pieces. It's pretty nascent. Don't run it. You will just get hurt. But definitely start looking at this as a pattern that you can bring into your own data center. And this is something you'll see the community pushing really hard on over the next little bit. So with that, I'd like to say thank you for your time. Have a lovely event. And you can hit me up on Twitter. I always say this, and no one ever does. So one day I'm actually going to have someone reach out to me. But I'm C. McLuck, CMCLUCK @twitter.com. And best of luck with the week.